Hello, I'd like to welcome you to CIS 657, Principles of Operating Systems. My name is Steve Chapin and I'll be your guide throughout this term as we study operating systems. I've been teaching and researching operating systems and security for about 30 years. I ported the Xenu operating system to 2 different platforms, and I've been researching and hacking kernel code of FreeBSD and Linux in my projects at the university. This is a graduate course in operating systems where we will be talking about the principles, design decisions, techniques, policies, and mechanisms we see. We'll study 2 modern operating systems. The primary one is an operating system for embedded systems and the Internet of Things, and that's the Xenu operating system I mentioned before. The secondary one, for contrast, will be a general-purpose time-sharing operating system, which is FreeBSD. The course philosophy is one that I derive from a saying that's been attributed to Confucius. It is that I hear and I forget, I see and I remember, I do and I understand. I really fundamentally believe to gain true understanding of operating systems, we need to actually program them. So what we will be doing is having a weekly lab where you will be developing an operating system, you'll be extending Xenu, and you'll be working on real hardware, a single board computer called the BeagleBone Black. The goals for the course are that you will become acquainted with the components and organization of hierarchically structured operating systems. I want to introduce you to research literature and show how the abstractions that underlie design choices are translated into running code. There are a couple of themes that I'll be emphasizing as we go throughout the course. One is that we're going to be exploring trade-offs. When we work in operating systems, there's often a continuum of possible choices without one single absolute best answer. So what we want to do is look at the choices we can make and understand what the trade-offs are, what the good and bad points are of different choices within that continuum. Also, I want us to walk away understanding there is no magic, that we can explain from the lowest level of the hardware up to the application level exactly how things come to pass. We want to understand how to bridge the gap from bare metal to the high-level OS abstractions and application processes. So what do I expect for the course? Well, my course is widely regarded as one of the hardest at Syracuse University, but it's also considered the most rewarding. So what I want you to do is immerse yourself in the material. If you focus on doing the labs, doing the homework, and really digging into the material, you'll get a lot more out of the course. So in conclusion, I do want to stress, though, that saying there's no magic here doesn't mean that this is dull. Operating systems are subtle and fascinating. As I said, I've been working in them in 30 years, and I'm still learning things. I believe that understanding computing is about building mental models. You need a solid grounding in operating systems to reshape those models and understand what the system is doing when you are using it. So let's have some fun and learn about operating systems.